Lecture 4, Aggregate Planning, Part 3. In this part, we will have an example and we'll see how can we apply the level and chase strategies and how can we compare these two strategies in terms of the total cost. Okay. So here we have a prototype example. Here we're assuming a washing machine plant which is interested in determining the workforce and production levels for the next 8 months. Okay, so the months are from January to August. So we have the forecasted demand for these 8 months. And at the end of December, we have 200 items in the warehouse. So the initial inventory for the beginning of the horizon, I mean, at the beginning of the January, we'll have 200 items in the warehouse ready to use. Okay, and also we would like to have 100 units on hand at the end of the August. So this is one of the constraints that we need to meet this constraint in our planning. So here is our problem, and we want to find the monthly production levels. Okay. So here we have the forecasted demand for the 8th month, and since at the beginning of the January we have 200 items in the warehouse, so the net predicted demand will be 220 for January, and the rest will be the same as the forecasted demand. And here we calculate the cumulative net demand. Okay, so we add up the demands over the month, and so as you see here, in total over the 8 months we need to produce 1940 items. Okay, and here we have the graph of the cumulative demand over the 8 months. Okay, yeah. So first, we are going to consider the level strategy, which is called constant production plan as well. Yeah, as you know, in the level strategy, we will have a constant level of production or workforce over the month. So because of that, it's also called here as constant production plan. So here we are going to level the production amount, production quantity. So we'll have constant production quantity over the month. Okay, so to do so, we just need to draw a straight line from the origin to 1940 units in month 8, and the slope of this straight line will be the production level of each month, which will be 1940 divided by 8, right? It will be 242.2, and we always need to round up the numbers, the decimals, so it will be 243 per month. Okay, so we see here. But if we take a close look at this graph, we will see in these periods we are in a stock out situation, right? So we'll have shortage in this month because the cumulative production, the cumulative produced items is less than the cumulative demand in that month, so we'll have shortage, right? So because of that, we'll say this production plan is infeasible, it's impossible, right? So in order to find a feasible solution here with no stock out situation, we just need to draw a straight line that goes through the origin and lies completely above the cumulative net demand curve. So to do so, we need to have this. As you see here, let me show with a different color. Yeah. So as you see here, it touches month 3, which is somehow our bottleneck here, and then goes straight here. So here the net demand curve, as you see, is crossed at period 3, right? So at the end of month 3, the cumulative demand is 960, right? And so if we divide this by 3, it will be 320. So this will be our constant level of production for monthly production. So now we do have a new straight line with the slope of 320 instead of 243, which was invisible. Okay. So now if we apply uh, the constant production level of 320 per month, now we can calculate the cumulative production level over the month. And on the left side, we do have the cumulative net demand, right? So if we subtract the cumulative production, if we subtract the cumulative net demand from the cumulative production, then we'll have the inventory at the end of that period. So as you see here, we do have inventory level 100, 140 here, and so in March, in the third month, March, the inventory will be cleared in order to satisfy the demand. But from April, again, we do have inventory at the end of the month. So this is actually the situation by applying the constant production level strategy by assuming 320 items to produce per month. Okay. But the solution obtained by the constant production level may not be realistic. So, for example, it may not be possible to produce 320 units each month with an integer number of workers. Yeah, because the work days are different in the month. So having constant production level per month doesn't mean that we'll have constant level of workers, right? So here we see that the level strategy by having the constant production level doesn't mean necessarily that we have a constant level of employees. So in order to resolve this issue here, we find a new parameter here, which is called K, and this parameter K is the quantity of aggregate unit produced by one man day. Okay, so for example, let's say in our historical data, we have a period of 40 days, and the plant had 38 workers during that 40 working days, and the plant has produced 520 units. So here we have 38 workers constant with no change over the 40 working days, and we have produced 520 units. So now if we divide the 520 by the 38 times 40, then we can obtain a quantity which is the quantity of aggregate unit produced by one man day. Okay, one worker per day. For this example is 0.3421. Okay. So as we saw, the constant production level may not be realistic. So now we are going to consider the constant workforce plan. So here we are going to assume that we will have constant workforce over the month. So in this example, as you remember, the critical month or the bottleneck somehow is the March. Okay, so the cumulative net demand through March is 960, and here we do have the working days per month. So as you see here, the January includes 22 working days, February 16, March 23, and so on. So as you see here, the cumulative number of working days from January to March is 61. So this means that we do have 61 days in order to produce 960 units to satisfy the cumulative net demand through the March, which is our somehow the bottleneck. So if we divide the 960, our requirement, by the 61 days that we have to produce that quantity, then we will find this 15.7377. This is units per day. This means that if we produce 15.73 units per day, then we will be able to satisfy the 960 units at the end of month March. Okay, so as you remember, in the previous slide, we obtained 0.3421 as the units can be produced by a 1-man day. Okay, so now if we divide 15.7377 by this k factor, it will obtain the number of workers that we need to meet our cumulative net demand through March. Okay, so which will be 46. So this says us that we need to have 46 workers in the company. So now let's see how, what will happen for the production, demand, and end inventory. So here the production level will be obtained by multiplying the number of units produced per day by the number of days. For example, for the first month, for January, will be 15.7377 times 22, which will be approximately 346. So we round up the numbers. Okay, so here by having this, we do have the production level. So as you see here, the production level is not going to be constant. It will be different over the month because of the different working days that we have per month. But the workforce will be constant. We will have exactly 46 workers over this 8-month horizon. We're not going to change the number of workers, but because of the different number of days per month, the production level will be different. Okay, so this column is the cumulative production level. So we do have the cumulative net demand, which it is our requirement, and here we can easily calculate the end inventory by subtracting the cumulative net demand from the cumulative production. Okay, and as you see here, this will be our end inventory over the eighth month. Okay, so now we do have a feasible solution by level strategy, by having a constant level of workforce in the company. And now we can actually, by having those data in the previous slide, we can calculate the total cost of this strategy for the company. So to do so, we need to have these data. The holding cost per unit per month, let's say it's $8.5. The hiring cost per worker, let's assume it's $800 per worker. The firing cost per worker is $1,250. Payroll cost is $75 per worker per day, and the shortage cost here is $50 per unit short per month. Okay, so by having these parameters, now we can easily calculate the costs of the constant level of workforce plan. Okay, so here we assume that at the end of December we have 40 workers. So since we do have 40 workers and we need 46, so we need to hire 6 new workers, right? So 6 times 800, $400,800 will be the cost of hiring here. And the inventory cost, so in that table, as you remember, we do have the end inventory per month. This means that we're going to keep, for example, 126 units for one month, one more month, from January to February. Okay, so yeah, these are the end inventory. So we just easily add up these numbers in order to have the total inventory per month, monthly in cumulative. And as you remember, in August, we assumed that we want to have 100 units in the warehouse, right? And so in that demand, the net demand that we had over there includes this 100 units. So this means that at the end of month August, we will have 100 items more in the warehouse because it's not the actual demand. So here we need to add up that 100 to 2,300 items here. So this means in total we'll have 2,193 units over the month. Okay, so now if we easily multiply this by 8.5, this will be our total inventory holding cost here. And for the payroll, $75 per worker per day. We do have 46 workers and we do have 167 days here. So this will be the total cost of payroll. So now if we add up all these costs, at the end we will have this number as 599,590.5. This will be the total cost of having a constant level of workforce plan. Okay. Now let's consider the chase strategy. It's also called zero inventory plan. It's not exactly zero. I mean, the inventory level will not become exactly zero at the end of the month, but we're going to minimize it as much as possible here by having the chase strategy. So we will have changes in the workforce over the month, but the inventory level will be minimum. So yeah, this is actually the chase strategy. We're going to match the production level with the changes in demand. Okay. So in the chase strategy, we will produce exactly the amount that we need to have in that month to satisfy the demand. So here we do have the number of days, working days per month, and as you remember, each worker per day produces 0.3421 unit. So if you multiply this parameter k by the working days, then it will be the number of units produced per worker in each month. So yeah, here we multiply the working days by the parameter k, then we will have the number of units produced per worker in that month. And here we do have the forecasted net demand. It's not the cumulative, it's exactly the net demand for each month. And now if we divide the forecasted net demand by the number of units produced per worker in each month, we can obtain the number of workers we will need in that month in order to produce that amount of demand. And here we round up the numbers. So yeah, as you see here, we do have changes in the number of workers over the month. So as you remember, we assume that we do have 40 workers at the end of month December. So by our calculations in the previous slide, in January, we need 30 workers. So this means that we should fire 10 workers in January, right? And then in February, we'll need 52 workers. This means that we need to hire 22 new workers. And then in March, we'll need 59. This means we need to hire 7 more, and so on. So here we do have the quantities for firing and hiring the employees, and then production produced per worker. We do have the numbers here. Because of the change in the working days, we do have different quantities here. And then if we multiply this by the number of workers, we will have the production here for each month. And so this is the cumulative production, this is the cumulative demand, and again, by subtracting the cumulative demand from the cumulative production, we'll have the end inventory here. Okay, so these are our end inventory. So as you see here, the inventory is not zero, but it's much less than the level strategy, right? Here we can modify the zero inventory plan. For example, for the second month, as you see in the table in the previous slide, we are going to have 11 items at the end of month 2 in our inventory. So look at here, each worker in this month is producing 5.47 items, right? So if we so here we have 2 workers, 2 times 5.47, which is almost 11 items. So this means that 2 workers are producing the items that are not going to use in that month and will be holding in the inventory. So this means that if we want to have zero inventory, so we can reduce the number of workers in this month by 2. So previously we had 52 workers in second month, but now we can reduce it to be 50. So we need to hire 20, not 22 in this month. Yeah, by the same analysis, we can reduce the number of workers in month 5, 6, and 7 by 1 worker in this month. So as you see here, we again could minimize the end inventory more than the previous plan. So this will be our final plan as the zero inventory plan. Okay. So now let's calculate the costs of this plan. The cost of hiring, here we do have these hirings. So if we multiply these hirings by the hiring cost, we'll have this cost for hiring. And the cost of firing, again, these are our firings. And so this will be the firing cost here. And for the inventory cost, again, we just need to add up the end inventory levels, and then at the end we need to add up the 100 units for the end of month August. So in total we will have 127, right? So this will be our inventory holding cost. And for the payroll cost, again with the same manner as previous case, we will have this number for the payroll cost, and at the end the sum of all these costs will be $560,000, and as you see here, it's less than the total cost of at the level strategy, which was about $590,000, right? So yeah, in this case, as you see, the chase strategy provided better result in terms of the total costs for the company than the level strategy. But we know that none of these two is optimal, right? And the optimal solution could be a case between these two. So because these two are the extreme cases. One says the chase strategy change the workforce in order to match the changes in demand, and the other one says that just have a constant level of workforce. So we know that none of these two is optimal. The optimal will be a mixed strategy between these two, and we will obtain that optimal solution by a linear programming model in the next part. Okay, thank you.